All right, guys, Chapter 7, Problem 6. Hello, chemistry fans, and welcome back to Chemistry 1032 problem-solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. So, without any further ado, let's jump into it. Classify each reaction as a combination, decomposition, single replacement, or double replacement. Okay. These are relatively straightforward things to do. They're really not all that challenging to do. So probably the easy way is just to do these problems and figure it out from there. Now, first one, we have two elements on the left side of the arrow becoming one element on the right. So these two things have come together or combined to make one new molecule. So this first one is a combination. The two elements on the left have combined to make one new molecule on the right. Combination. All right, next one. Sorry about the 2 and the 3 not being subscripted there. That's a little bit of an error on my part. But this is a single replacement. Now let me show you how I came up with that. Here we have a carbon element all by himself on the left and an iron element all by himself on the right. Single replacement reactions do that. You'll have one element, doesn't have to be carbon, can be anything, that will combine with stuff over here and give you a new element on the right. So here we have a carbon on the left and iron on the right. So in essence, the iron has left the oxygen to go by himself. The carbon has joined the oxygen to go on with the oxygen. So the carbon has switched places with the iron, and the iron goes by himself. But the key is one element on the left, a different element on the right. This is a single replacement. Single replacement. Okay? This one here. Here we have a molecule on the left and two molecules on the right. So one thing became two. It could have been two things over here becoming three as well, so be mindful of that. So one thing becomes two. This is a decomposition because this is falling apart to give me two other things. Decomposition. And the last one. So we have sulfuric acid and KOH becoming this and that. So hydrogens are with the sulfate on the left. Now the hydrogens are with the oxygen. Over here the potassiums were with the OH, and now the potassiums are with the sulfate. So what's basically happened is this potassium and this hydrogen have switched places. And that's all that's really happened in this reaction. So this is a double replacement reaction because two elements are being replaced. The hydrogen is being replaced by the potassium, and the potassium is being replaced by the hydrogen. Notice there's no single element on the left, and there's no single element on the right. Up here, with a single replacement, we had an element on the left, a different element on the right. We don't have that here. The K and the H are simply changing places. So this is a double replacement. A double replacement reaction. All right? Now, I hope that you guys were able to solve these problems, or at least this video was helpful to you. If not, please contact one of the many tutors we have here at the Academic Success Center, or come on by and see your professor during office hours. And with that, I'd like to wish you good luck and good chemistry.